Hello, this is Mrs. Myers, and we're going to today be starting Unit 1, Lesson 6, which is about parallel lines. Some of this will be familiar to you. We're going to review some of the terms that you've learned before and then put them into kind of a new context as we apply them to writing some proofs. So there are some postulates and theorems that help us to understand angle relationships and find missing angle measures when we know we have parallel lines. So this first postulate is called the same side interior angles postulate, and it says if you have parallel lines, so in this case line L is parallel to line M, and it's cut by a transversal, this is called a transversal, then what are called same side interior angles are supplementary to each other. So in this case, same side refers to the transversal, two angles that are on the same side of the transversal, but are between the two parallel lines. So in this case, we have 3 and 6 are same side interior angles, and they're going to be supplementary, meaning they add up to 180 degrees. And on the other side of the transversal, we have another pair that are 4 and 5. Those are another pair of same side interior angles, and they are supplementary as well. Okay, so that's a postulate. Notice it's a postulate because we need one of these statements to be a postulate, because then we can use that particular statement that we accept as being true to then prove the other ones, and the rest of them become theorems. Okay, we'll explore that a little bit more at another time. But all of these theorems and the first postulate are basically saying if you know the lines are parallel, so the hypothesis in every single case is that the lines are parallel, then, right, the conclusion is that there's some relationship between the angles. The first one was a postulate. It said that the same side interior angles were supplementary. The rest of them are going to show some congruences. So the next statement we have is actually a theorem, and it's called the alternate interior angles theorem. The alternate interior angles theorem says if the lines are parallel again, then angles that are on alternating sides of the transversal. So the other one was same side. This is alternating sides, right? Interior refers to between the parallel lines. So like this is the interior. Okay, up here, right? Same side interior. This is the interior between the two parallel lines. Anything that's above, like up here or down here, that's exterior, right? So we're just talking about the same side interior angles. Oopsie, I need to go back to my pen. Okay, so with this one, we've got alternate interior angles, alternating sides of the transversal. So this time we want one on this side and one on this side. So these are alternating sides of the transversal. They're called alternate interior angles. And in this case, they're going to be congruent if the lines are parallel. We got two pairs, 3 and 5 and 4 and 6, alternate interior angles. Now, sometimes we refer to alternate interior angles. You'll hear me say, look for the Z, because here's one of the angles, right? And then here's the other angle. And so it kind of looks like a Z pattern. Even if you go the other way, I know it's not exactly the Z you would draw, but it looks sort of Z-ish. So sometimes it helps to kind of look for the zigzag Z to identify alternate interior angles. All right, let's look at the next one. This is the corresponding angles theorem. Corresponding angles refer to angles that are in the sort of the same position on one line, so like let's say on line L versus on line M. Meaning, if I highlight this angle right here, and then kind of slide that down into the same position down on the other line, those are corresponding angles. So I have angle 1 and angle 5 are in the same positions as each other, right? I could do the same thing with, let's say, angle 2. And I slide it down, and angle 6. So 2 and 6 are corresponding angles. Okay, and then you can see angle 1 and 5 we mentioned already. 2 and 6 we mentioned already. But underneath here we have these as well. 4 and 8. Right? We could slide that down, slide 4 down, and it would cover where 8 is, and then 3 and 7. So there's 4 pairs of corresponding angles, and they're listed here. Okay? And those are congruent. Alternate exterior angles. Again, the hypothesis in all of these is that the lines are parallel. So corresponding angles like this are only congruent if the lines are parallel. If the lines weren't parallel, we could still have a transversal. We could still have corresponding angles, this one and this one. But would they be congruent to each other? No. Right? If the lines are not parallel, then there still exists corresponding angles, but they are not congruent to each other. So all of these theorems are under the assumption, the hypothesis, that the lines are parallel, and that's what makes these special angle relationships. Okay, so the last one here, alternate exterior angles. Like we said before, the exterior is going to be everything besides the interior, right? So the interior is between the lines, and the exterior is kind of above and below. So alternate exterior angles are going to be alternating sides of the transversal, but on the exterior. So one up here and one down here. That's alternate exterior angles. One down, one up there, and one down here. So there's 2 pairs of alternate exterior angles, and they are congruent to each other. So basically, if you have 2 lines that are parallel, cut by a transversal, there's really only 2 angle measures. Because think about the linear pairs and vertical angles that exist here as well, right? If I have this angle is, let's say, 50 degrees, then I would know this angle is 50 degrees. And I would know this angle, since it's a linear pair to both of those, would be 130 degrees. And then the vertical angles here, that would be 130 as well. Well, now that we learned about these lines that are parallel, and by the way, the marking for parallel lines is this little extra arrow. If you see an extra arrow on both lines, that means the lines are parallel. Okay? We can use any of the 4 theorems we just talked about to mark the rest of these angles in this diagram, right? This angle 50 here is corresponding to this one, so this has to be 50. And then we can just finish everything out, right? Because it's going to be the same exact situation on this line as it was on the top line. And then you can see alternate exterior angles, 130 and 130, right? Corresponding angles, 50 and 50. Alternate interior angles, the Z. Let's do the Z, right? 50 and 50. So you can see all of these relationships. Same side interior angles. Same side interior angles. 130 and 50, right? Because we said same side interior angles are supplementary. I like to think of the S, right? Same side, they're going to be supplementary. All right, so let's see how this applies here. Look at the diagram to the right. All of these angles, if we just know one or two of them, we could end up being able to figure out all of them based on these relationships. So if we know that the lines are parallel, angle 1 and angle 11, right? So it doesn't actually say these lines are parallel, but we're going to say that they are. Actually, I think we say that they are down here. So that's for those exercises. So these were just naming the actual names. 1 and 11. 1 and 11. That's the, oops, this down. That's the one that we can slide, right? So that's going to be, oopsie, corresponding angles. Okay, I'm going to let you pause the video and try to fill these in yourself, and then come back and fill them in. Check your answers when you're done. So pause the video. Okay, so these are the answers you should have gotten here. Remember, refer back to the first page if you're unsure of what those were supposed to be. All right, given the diagram below, now they are telling us that EF is parallel to GH. So we can mark them parallel with these little doohickeys here. Find the missing angle. So they're telling us the measure of angle 6 is 35. Mark your diagram. Oopsie, why did that happen? And the measure of angle 12 is 120. And they want you to find the rest of the angle measures. So in a case like this, I would work off the diagram before I go trying to answer all these questions. Just fill in what you think you would know here. If you know these lines are parallel, if this is 35 degrees, angle 6, then a vertical angle to that would be 35 degrees also. And then our new theorem about same side interior angles, if this is 35, this has to be supplementary to that, and we should be able to fill in that angle, which is 145 degrees, because 145 plus 35 is 180. And so in this way, you should be able to fill in the rest of the angles. Again, I'm going to have you pause the video, try to do as many angles as you can, and then come back and check your answers. All right, I decided that we need to explain some of this before they all get filled in. So I went to angle 11, and this would have to be 60 degrees because of the linear pair situation here. 120 and 60 make 180. This one is 35, is like this one because they're alternate interior. There's the Z, right? So then this is 35 because it's vertical to angle 8. So then angle 9 is going to be 145 because it's vertical to angle 7. And then I can do angle 4 is 60 degrees because it's same side interior with 120. All right, and then from this point, we can see that even though it's not called a linear pair, it's still this whole situation here is 180 degrees, right? So if we have 60 here and 35 here, then we need 85 more to make the whole 180. And if that's 85, this would have to be 85. We've got vertical angles here is 60 degrees. And then since we have 60 degrees here, the linear pair to that, or you could think of it as vertical angles this way, this has to be 120 and 60 as well. So that should be all of them now. And you can fill them in here. Okay. All right, so numbers 8 and 9 then are going to be solving using that same diagram, but with some algebra. Okay, so we're going to use some algebra here for this one. I had to change this to match yours. Okay, so if we go back, we're not using these measures, but we are using this diagram. If the measure of angle 1 is 16x minus 4y, and the measure of angle 12 is 14x minus 20y, and the measure of angle 11 is 6x minus 8y, we have to notice here that we have two variables, so we need to write two equations. So we need to look at the different relationships here. So I can relate 11 and 12 because they're a linear pair. So linear pairs add up to 180. So here's my first equation. Measure of angle 11 plus measure of angle 12 equals 180. And then I can relate angle 1 to angle 11 because they're corresponding angles, and corresponding angles are congruent to each other, so that makes the measures equal. So there's my second equation right there. If I simplify both equations, I get 20x minus 28y equals 180, and 10x plus 4y equals 0, if I put them both in standard form there. Then what I want to do is use either substitution or elimination to get these things to cancel out one variable. Okay, so at this point I'm looking, and I think I can divide this whole thing by 2. It might make my life a little bit easier, right? Divide by 2, I'm going to get 10x minus 14y equals 90. Oh, look at that, I could divide even further, get this to be smaller. So I can divide everything by 2 again, actually. And I'm going to get 5x minus 7y equals 45. Yeah. So at that point, I can either use substitution or elimination. Looks like I should use elimination here because I don't see any variable that I can just automatically, isolate. So I'm going to put this equation here and try to get one of the variables to cancel out. Looks like I should multiply this, though, back through. I guess I should have left it with my 10, right? It would have been better if I still had my 10x because I wanted to, so I'm going to multiply this back through by negative 2 to get this to be a negative 10x plus 14y equals negative 90. And then we are adding our two equations together. This cancels. This is 18y equals negative 90. And so y equals a negative 5. So if y is negative 5, then I should be able to plug that back in to solve for x. So I'm going to go back to this equation right here, plug y in as negative 5, and solve for x. X turns out to be 2. And then when you have x and y, you should be able to plug in to all of these to find the measures of each angle. So pause the video, do that, and come back. All right, so these are the answers you should have gotten there when you plug x and y back in. So I'd like you to try number 9 on your own, using the relationships, knowing the lines are parallel, write some equations, and solve for x. This one is just x, but you are going to have to factor. Okay, so pause the video, try that, and then come back. Okay, so the equation you should have written here for 6 and 7, since 6 and 7 are same side interior angles, that makes them supplementary. So they add up to 180 degrees. So here's the equation you should have written. You have to factor. When it turns out you have two solutions here, and one of the solutions is negative 1/3, and the other one is 10. We plug in negative 1/3 for the measure of angle 6, and it turns out that measure of angle 6 is negative. So 1/3 cannot be considered an actual solution to this problem. So we have to use 10, and when we plug in 10, there's the answers we get. All right, so now let's look at some proofs. And I'm just going to do one proof with you so that you get the idea, and then you're going to try the rest on your own. I think you will get the idea here. So given that L is parallel to M, and we can see it's marked with this little extra arrow here, the measure of angle 4, again, mark your diagram, is 3x plus 17, and the measure of angle 6 is 5x minus 23. So hopefully when you mark your diagram, you're noticing what type of angles these are. And these are alternate interior angles. They're like the Z. So we're going to start again, just like we did before, by putting our givens into a box each. And then look at your diagram and kind of say, well, what other relationship do I have? And we're going to write a general equation over here. Now, angle 4 is congruent to angle 6 is the statement we're going to make. Because if you look back at the theorems that we learned, right, alternate interior angles theorem, it says that they're congruent. It doesn't say the measures are equal, it says that they're congruent. So when we're writing a proof, we have to stick to exactly the way the theorem is worded. And the alternate interior angles theorem is going to be our reason, and that theorem has a congruence in it. So in order to be able to substitute, we have to turn this into the measures being equal. Hopefully we know this now as definition of congruent. So we found our relationship, and now we're ready to plug things in. By the way, this parallel actually contributes to this statement, that the alternate interior angles are congruent, right? The theorem says if the lines are parallel. So I'm going to change this and put my given if the lines are parallel. That really is the top given here, and it leads you to be able to make this relationship. That's really important, that, you know, alternate interior angles are only congruent if the lines are parallel. So I'm going to kind of put that parallel at the top, and then it points to alternate interior angles theorem. Okay, and then the measure equal. Now we're ready. After we wrote our general equation, we can now substitute. 3x plus 17 equals 5x minus 23 by substitution. And you should be able to know how to proceed from there to prove that x is 20. Let's look down here. I'm just going to get you started on this one. L is parallel to M again. Measure of angle 1 is negative 6x minus 9, and measure of angle 7 is 2x plus 87. And again, you want to think about what is the relationship here, and angle 1 is going to be congruent to angle 7 because of the alternate exterior angles theorem. So you need to be able to recognize what type of angles this is going to be more vocabulary that you really need to be able to do. Here, if we look at this next one, the measure of angle 3 is 3x plus 21. Measure of angle 6 is 12x plus 39. Now, hopefully you recognize here that these are not congruent, but they are same side interior angles. So the measure of angle 3 plus the measure of angle 6 is going to equal 180. Right? Actually, that's going to be our, oopsie. Can't say that yet. First, we have to use the word supplementary. Angle, okay. Right, angle 3 and angle 6 are supplementary because the actual postulate says the word supplementary. So same side interior angles postulate. Then you can say measure angle 3 plus measure angle 6 equals 180 by definition of supplementary. So this is similar to like the linear pair postulate. Uses the word supplementary, so we have to actually put that statement first and then the measures equal. Okay, so I've sort of set you up to try to finish these proofs on your own and practice more in class.